Before now, you've been doing derivatives using the formal definition, which involves limits, and it's pretty long. So now I'm going to teach you some rules that will make them go a lot faster. Our first rule is called the constant rule. And the constant rule says that the derivative of any constant is always going to be 0. So for example, if we have f of x is equal to -3, then f prime of x is equal to 0. This is also true for constants that aren't just numbers, that aren't just integer numbers. For example, if you have something like f of x is equal to e to the 57 power, it looks really terrible, but actually e to the 57 is a constant, so its derivative is still going to be 0. Our next rule is called the power rule. So for the power rule, if we have x raised to a power, like x to the n, what we're going to do is we're going to subtract 1 from the exponent and move the previous exponent out front. So I'll do an example or two. So for example, if you have f of x equals x to the 5th, your derivative is just going to be 5 times x to the 4th. So you move the 5 in front, and then you subtract 1 from the 5, and you get 4. Similarly, if you have like x to the -2, you are going to move the -2 in front, and then you're going to subtract 1 from the -2, and then you get -3. Now, let's look at the x to the -2 again. Sometimes that's not going to be written as x to the -2. In fact, it's usually not. So let's say you have something like 1 over x to the 4th. In order to do this problem, we can use the power rule, but we need to rewrite it. So keep in mind that 1 over x to a power is the same as x to a negative power. So now when you have that, you can solve it and find the derivative, but you have to rewrite it first. So finding the derivative of that, we get -4 times x to the -5th. It's a good habit to get into, or it's good practice to rewrite this so that you don't have negative exponents. However, to be honest, I don't care if you don't simplify it all the way, as long as you get to the step before this. So you don't have to simplify it, but it's a nice thing to do, especially if you're doing a test that has multiple choice questions, like the AP tests. There's a lot of multiple choices. It would be given to you as a fraction. So another case that you might see is something like y equals the cube root of x squared. By the way, you'll notice I wrote it as y and not f of x. It's the same idea. The only thing is that your derivative is going to be y prime. So in order to find the derivative of the cube root of x squared, we have to rewrite this as x, and then we're going to get a fractional exponent. It's going to be x to the 2/3. So now what you're going to do, in order to take the derivative, you pull the 2/3 out front, then you're going to subtract 1 from 2/3. If you subtract 1 from 2/3, by the way, it's not -2/3, it's -1/3. So be careful about that. Make sure that you're okay with subtracting 1 from fractions. A lot of people make little mistakes on these. So I'm going to just rewrite my answer as 2 over 3, and then it's times x to the 1/3 power, which is the same thing as the cube root of x. So our next rule is the constant multiple rule. So basically all the constant multiple rule says is that if you have a number being multiplied by a function, then that number is also going to be multiplied by that function's derivative. So let's do a few examples. So for example, just do actually one for this. If you have f of x is equal to 8x cubed, f prime of x is going to be 8 times 3 x to the second. Remember, you pull that 3 up front and then you subtract 1 from the 3 to get an exponent of 2. Your final answer for that one is just 24x squared. The last one is called the sum and difference rule. The sum and difference rule is pretty nice. It's basically just telling you that if you have some stuff added or subtracted, then their derivatives are going to add or subtract. I'm going to make a side note, and that side note is that this does not work when you have products or quotients. So it doesn't work when you're multiplying or dividing. You don't need to like write that down if you don't want to, but I just want you to keep it at the back of your mind. For multiplication and division, we have two separate rules, and they're a little bit more complicated. Addition and subtraction, though, are very nice. So I'll give you one or two examples. For my first example, I have f of x equals x cubed minus 2x squared minus 3. The derivative of that one is just going to be 3x squared minus 4x. Derivative of negative 3 is 0. So this next one, feel free to try it on your own. I'm just going to give you one that's a little bit more complicated. So if you would like to pause this and try it, go for it. Okay, so for this problem, I think this has a little bit of everything in it. Before we find out what our y prime, what our derivative is, I think we need to rewrite it. So first of all, 3x to the fifth, we can just leave that as is. So this minus 1 over 5x, I am going to write that as minus 1 over 5x to the negative 1. Be really careful about that one. Sometimes people try to move the 5 to the top of the fraction, but that's actually going to stay there. Only the x is going to move. Then I get plus 3x. The fifth root of x squared is going to be the same thing as x to the 2/5. Now we can actually evaluate this. So we get y prime, that's my derivative, remember, is equal to 15x to the 4th plus, remember I'm multiplying by negative 1 over 5x to the negative 2. I subtract 1 from my negative 1. Plus, I have 3 times 2/5, which is 6/5. I'm going to subtract 1 from my exponent. That's going to give me negative 3/5. This actually is a perfectly acceptable answer if it was a free response question. Most likely you wouldn't get this something like this as a free response. It would be a multiple choice, which means that you do have to go on to the end and figure out what the simplified form is. So 15x to the 4th stays the same. 1/5 x to the negative 2 is actually going to be 1 over 5x squared. This last one, I have 6/5. 6 is going to stay on the numerator. However, 5 is going to stay in the denominator, and x to the negative 3/5 is also going to move down. It will become the fifth root of x cubed. The last thing I want to talk about is the derivative of e to the x. So keep in mind that e is a constant. It's equal to approximately 2.7172. It comes up so often in real life, like with population functions, that it's actually a very important function. The other thing about it that's really, really important is that it is also, it has a unique derivative. So the derivative of e to the x actually is equal to e to the x, believe it or not. So if you keep taking you just take the derivative of it, you get what you started with. There are a few cases where you're going to get something different. Like if you have like e to the x, x squared or something, you will get something different. But if it's just plain e to the x, the derivative of that is e to the x. So we'll do an example or two. Okay, so for this example, feel free to pause and try it on your own. So the derivative of this, we're going to put our 2 up front. Remember, once again, the derivative of e to the x is e to the x. It's actually the only function whose derivative is equal to itself. So then that's just going to be 2 e to the x, don't overthink that part, plus 27, I multiply 4 times 7, times x to the third, I subtract 1 from my 4. I'm going to rewrite this as 2x to the negative 1, and I get minus negative, so it becomes plus, 2x to the negative 2. Last thing I'm going to do is just write this out so I don't have that negative exponent. And this is my answer.